Did you know that you can turn a $50 toaster oven into a $500 reflow oven without having it look like this and more like this? Let me show you how to do that in this video. A lot of these SMD components are absolutely tiny, and using a soldering iron just isn't going to work. Modern electronics are packed with hundreds of these, and the only really reliable way to do it is by solder paste and reflow oven. I went online and found myself the cheapest toaster oven I could get my hands on. This one is 650 watt, but you would aim for something around 1200 or around that number to make sure it can heat up at a fast enough pace. First things first, we crack it open, and it can look intimidating, but there's only really two things that we care about in there. That's the heating element and the wires that power it. Before I touched anything, I needed to understand how the heater actually was wired. So I found this diagram online, same concept. Main voltage goes in, runs through a switch, and out through the heating element. All we're doing is we're replacing the switch with the Arduino. I sketched it out. On the low voltage side, you can see the Arduino, the thermocouple, and on the high voltage side, it's just the SSR sitting in series with the heater. The two sides are separated. And just a quick safety note, we're dealing with high mains here, so if you're not comfortable with that, and get some professional advice before you plug in anything. Here's the full wiring diagram. I'll link to this in the description. The thermocouple goes into a MAX 6675 module, and that's just an amplifier that converts voltage to something that we can read on the Arduino. So it talks to the Arduino over SPI with 3 wires. The OLED display is on I2C, 2 wires. And then we got 2 buttons on pin 4 and 5 for the UI. In real life, this can look like this, and it's a bit messy, but it doesn't matter. It worked in the end. Here's the final model of the oven, and this is just a teardown to show you what's actually inside. First, we see the joint sleeves connecting the power wires and the heating, and then we got the SSR relay with 2 output wires to the Arduino, and then we got the fan and some light and the main power supply connected to the grid. So let me quickly go over the code. It might look a bit complex, but it's really just following a recipe. What we have here is the solder profile of the solder paste that I'm using. So we have a preheat stage, we have a soaking stage, and a reflow stage. And the way that this is used is in this main function here called calculate set point. What it does is that it calculates what the temperature should be at these different stages, and then we compare that to the actual temperature to activate some control logic. And we have 4 different phases. We have the preheat phase, where the temperature rises to 150 degrees, and this is really just to prevent any thermal shock. Then we have the next stage, that's called the soaking stage. And here what happens is that the flux in the solder paste begins to activate. There might be some moisture on the PCB, begins to evaporate. Then the last stage is the reflow stage. And what happened here is that the temperature increases rapidly, and the actual solder paste begins to melt and bind with the pad of the PCB and the component. And then after this, I would just open the oven to release the heat in a steady manner. This is the way basically that the oven works, by calculating the set points, and then we draw the actual temperature with the curve of what we expect to see how it actually performs. And what you would have to change if you were to do this is that you would have to change these values depending on the solder paste that you use, and you would also have to change the PID control settings. So we have the proportional gain, integral gain, and the derivative. And these I changed based on output from the terminal. So I would crank the oven up and try to follow this profile that I set, and then see how it matched with the graph in another script that I have put in the description. And then I would tune these parameters for each run to see if the oven actually followed my profile. And this was done by iteration. This is the moment where we turn on the oven and it's warming up, as you can see on the OLED display. The oven is open to warm up the whole thing at a steady temperature. And you can see that the probe is still pointing out. So I placed the PCB in the oven on this baking sheet. Now we're in the preheat stage, so the flux is still not totally melted. And we're just warming up the PCB. And you can see I'm watching intensely, waiting for the flux to melt. So now we're in the reflow stage, 183 degrees and climbing. This is where the controller is tracking the curve live, and you can see it's drawing the temperature graph in real time. So the target is to hit 217, and then the SSR cuts off. And here you just stare at it until you can see the liquid is melting more or less. And now the cake is ready. But before you do anything, then let it cool down inside the oven and not aside it here. All right, so that's it for under 50 bucks. And just a weekend, you can make yourself your own reflow oven and have a PCB that looks something like this after, and almost following an industry standard reflow profile. Thank you, and see you in the next